Okay, so I am for sixth period. You guys are going to have, I want to do a couple more examples since we don't meet live until Friday. So I want you to see a couple more of these inequalities with your calculator graphically. So I give you this equation. Again, like yesterday, I would suggest zeros. So make this so that you have 0, which means I would just subtract 20. So now I'm saying, when is that graph less than or equal to 0, which would be below the x-axis? So no work, get out my calculator, y equals, put in 2x squared plus 3x minus 20, graph it. So I look at that picture and I think, when is it below the x-axis? Well, I know that it's a parabola, so I know from there to there, which is one connected part. One connected part means one interval. So what do I need? My zeros. Second trace number 2. Left bound, just follow that thing, enter. Right bound, enter. -4. So that's that 0. I go do the other 0, number 2. Left bound, just get close to it, but don't go past it. Enter, enter, 2.5. So when is it below the x-axis? Any x from -4 to 2.5. I look at the inequality. It has an equal sign. I put brackets. If I did this one, it's all ready to go. So I get out my calculator, y equals. The thing with these, there is no work to be shown. What some people will do is draw a picture like me dragging the graph, just to get an idea of what they're supposed to do. Now this one, I like this one because if we look at that, when is it below the x-axis? Well, I would hope that you guys would say never. Well, so if it's never, you're going to say no solution for below. Now, what if I said greater than 0? Well, where's it above 0? Everywhere. So everywhere means all real numbers, which is -infinity to infinity. If we have a cube, no different. So we can do with our calculator any type of equation as long as it's a function. So x cubed plus 2x squared minus 1, graph. Zero's on a side by itself, so I'm good. Now, the only thing with this one, which I will go over more in person, when is it greater than 0? Well, you can clearly see that part. So you could get your calculator above 0, and you could do second trace 0, left bound, right bound. That 0 is 0.618. So I know it's got the equal sign, bracket, smaller always before the larger. Anything from 0.68 to infinity, it's above. But I don't really know what's happening by -1. So what we do with that is I'll teach you how to use something called Zoom Box. If you press Zoom, it's number 1. Now, Zoom Box, this little like cursor, you can see it moving around. You want to go to the top right corner of what you want to investigate. So I'm like at -0.5. I press enter and it becomes a square. Then I move left and down and you make a box. You then press enter and it gives you that little part zoomed in. So now you go back and you think, okay, when is it above 0? Well, from there to there, it's above 0 also, which I couldn't see in that picture. So then you do the same thing, just in that window, find those zeros, go to the left, go to the right. That is -1.618. And then find the other one, which is second trace, number 2. I go to the left, I go past it to the right, and it's -1. So the other part of my answer would be -1.618 to -1. And again, those are in brackets because it has the equal sign. So that just gives you a few more examples. Last thing that we're going to use our calculator for, again, if you're using Desmos, it probably works the same way. Projectile motion model, quadratic, -16t squared plus vt plus s. You also saw this like in Algebra 2, height of at a given time. So this is height at a given time, t. -16 is always -16. V is velocity. S0 is starting height, initial height. The thing you want to think, we're doing these with a calculator. We are not doing any work by hand. So if I have that model and I say to you, this is bad English, but it's just like a, I sort of took it. I have some rocket, firework, whatever. I launch it straight up from the ground with a velocity of 288 feet per second. So using that model, I would have h of t equals -16t squared plus 288t plus 0 because it went from the ground. Now, I'm going to ask you these questions using that model. Well, when is the height above 1,152 feet? Well, really, that's saying, when is this -16t squared plus 288t above, or equal to, I'm sorry, above the ground? When will the height above the ground be 1152? Now, you guys will see with me with word problems, I like to do intersections because of my window. So I go to my y equals, I put in -16x squared plus 288x. In another y equals, I put in 1152. Now you have to think of your window because like obviously even at Zoom 6, you're like, I don't see it. Well, you just put in a Y of 1152. So you definitely need your Y max to be like 1500. Now you don't want to go by ones, you would want to go by like hundreds. Now X, T is time. It's not going to be that long and it's not going to be negative. So I just do like trial and error, -1 to 20, let's say, to start. If I graph it, there's the quadratic, there's 1152. When is it 1152? Well, that's going to be at the intersection. So it's going to hit it twice, going up and going down. I hit the wrong thing, sorry. Number 5. So I would do enter, enter, enter. It's 12 seconds. And number 5, get closer to that other one with intersection. Enter, enter, enter. 6. So I would say T equals 6 and 12 seconds. So that's just a start. You can see what you can do with that. Hopefully that will help. We will see you tomorrow. Bring all and any questions to class.